So what I'm going to be teaching you today is how to add vectors together, okay? So here's a vector u, and we're going to add to that vector v, and the result of adding these two vectors, remember, to add vectors, we go head to head to the tail, right? And so that, if we add these two vectors, it would give us this vector right here, and there's a direction and a magnitude size to this, right? And so I'm going to call this one r, all right? And the way we're going to get r is we need to get the horizontal component of r and the vertical component of r, and then use those to get the angle of the triangle and also the magnitude, okay? So the way to get this is this right here. So if we shift this down right here, then this becomes this horizontal piece right here, which is made up of u sub x and v sub x. That becomes the horizontal component of r. So r sub x would equal u sub x plus v sub x, okay? And that's going to be the horizontal component of our vector r. And then to get the vertical component, so the vertical component is made up of the vertical component of u plus the vertical component of v. So that would be this whole thing right here. So r sub y is equal to u sub y plus v sub y, the two vertical components. All right. Now, occasionally, depends on where everything's located. All right. One of these or both could be negative. Same thing with u sub x and v sub x. So sometimes because of where they're located, it's going to give us a negative value, which we will combine. All right. Okay, so then the other thing, all right, now we can get the magnitude because we have the horizontal and vertical components of r. We can go and get the angle of the triangle. We can also get the hypotenuse, right, the magnitude. So I know vector r is going to equal the square root, its magnitude will equal the square root of r sub x squared plus r sub y squared, the horizontal and vertical components. And I also know my angle alpha is going to equal tan inverse of r sub y, the vertical component of r, over r sub x. And again, keeping in mind, these both have to be positive to get the angle of the triangle. And then we can use that to get our angle, our direction angle, okay? Or our angle of rotation. When I say direction angle and angle of rotation, those are the same thing, okay? So these are the steps that I've lined out for you guys. Okay, so we want to find the horizontal and vertical components of each vector. Sometimes if it's a description, we're going to have to figure out what the direction angle is for each of these. Okay, I have an example that I'll do that with you guys. And then we want to find the sum of the horizontal components. And then we're going to want to find the sum of the vertical components, because that will be the horizontal and vertical components of our vector here. All right. And then we're going to draw a diagram using the horizontal and vertical components of the resultant vector. Okay. And so that will place us in the right quadrant. Okay. And again, we'll draw the horizontal one first. Okay. We'll need to draw that one first. All right. And then use the horizontal and vertical components of the resultant vector to find the magnitude. And that's what we're going to do right here. And then the direction of the resultant vector. And this would start to give us the direction angle right here. Okay. All right. So let's go do some problems. All right, so we want to add the two vectors. One of them is 45 meters per second at 120 degree angle, and the other vector is 20 meters per second at a 45 degree angle. Okay, so we're going to look at the 45 meters per second, okay, and at 120 degrees. All right, so what happens is let's call this one U. Okay, and so u sub x is going to be 45 meters per second cosine of 120 degrees. And my u sub y is going to be 45 meters per second sine of 120 degrees. Okay, and then the other vector is, let's call V, and V is going to be 20 meters per second at 45 degrees. And so the horizontal component for that one, I just wrote U and I meant to write V. Okay, so V sub X is equal to 20 meters per second cosine of 45 degrees. And then the vertical component V sub Y is 20 meters per second sine of 45 degrees. I don't want to put this in yet, okay? So what, I don't want to put in the calculator yet, all right? Because what I want to do is when I write my R sub X, I want to take this horizontal component and add this horizontal component. And I don't want to have to worry about signs or anything else. So I'm just going to take the 45 and we're just going to put it straight into our calculator, okay? But we're going to write here 45 meters per second cosine of 120 degrees. And then we're going to add to that this horizontal component, which is 20 meters per second cosine of 45 degrees. Okay, and then we're going to put that into our calculator. And I'm going to round more decimal places than I need, okay, because I want to be accurate. At the end, I want to be accurate. So I need more decimal places in order to be accurate at the very end of all this, okay? So in my calculator, I'm going to type in 45 and then cosine 120, close the parenthesis. Make sure you close the parenthesis, okay? And then plus 20 cosine of 45. And I'm going to round this to 3 decimal places, okay? So we get negative, so this comes out to be negative, right? So negative 8.358, okay? So negative 8.358. Okay, and now we're going to get R sub Y. So R sub Y is equal to, and it would be 45 sine of 120 degrees, so 45 meters per second. Sine of 120 degrees. And then plus 45, not 40, 20 meters per second. 20 meters per second. Sine of 45 degrees. Okay, and I should have, and I didn't, is this is in meters per second. Okay, and then we're going to put this one in our calculator. Okay, so 45 sine of 120, and then plus 20 sine of 45. And we get positive 53.113. Okay. So now, all right, we have, okay, so now it's just like Tuesdays or Wednesdays work, okay? We have the horizontal and the vertical component, right, of this vector R. So now what we're going to be able to do is I'm going to draw a diagram because I want to get my angle of rotation correct, okay? And the only way to do that, I think, is really to draw a diagram, okay? So right here, I'm going to go right here. And I know I'm going to draw my horizontal component first. So that means I'm going to have to go left and then up. So I'm going to go left. And again, this is not drawn to scale, so it's fine. Okay, this is going to be negative 8.358. And that's meters per second. And then we're going to go up this 53.13. And again, it's just a drawing to orient us. The important thing is we're going left and up. That's what's important, not how long this is. Because this is definitely longer than this one because it's bigger. It's a bigger value right here, 53.113. Okay, so this right here is going to be my resultant vector R. Okay, and I can get that. I can get R by taking the square root of, And I'm going to use the decimal here. So negative 8.358 squared plus the 53.113 squared. Okay, so I'm going to put that into my calculator. Negative 8.358. And parentheses around it. Because it's a negative value, you got to put parentheses around it. And then squared. I keep saying that because that's a common mistake, okay? And then parentheses, and then 53.113, and then squared. And we get this, right? 28,000, or not 20,000, 2,890.84. And I'm just going to go ahead and take the square root of that answer. And we get 53. And I'm for the final magnitude, I just want to round to one decimal place. So that 6 right here is going to make the 7 become an 8. So 53.8. So this becomes 53.8 meters per second. Okay, so that's the magnitude of it. All right. So now I got to get my angle, right? And so I'm going to get my angle right here, alpha. That's the angle of the triangle. And so alpha will equal, okay, and it's going to be tan inverse. And once again, it's going to be the vertical piece, 53.113, making it positive, over the horizontal, which we're going to make it positive, okay? Because we got to think of this as being a triangle, so these are like lengths, okay? So 8.358, and that gives us to the nearest degree. Okay, so I'm going to press second, tangent, and then 53.113, and then divide by 8.358. This should give us a pretty big angle. Yeah, 81 degrees, right? Okay, so I need to get this angle that I'm rotating around, right? Which is my theta, okay? And so what I need to do is I need to go all the way to 180 degrees here and then back up the 81 degrees. So my theta is 180 degrees minus 81 degrees, right? And that would give you 99 degrees, okay? All right, so we're ready to write it, okay? So what is our vector? The resultant vector is this. It's gonna be 53.8 meters per second in a direction of we can say at 99 degrees. Now, the descriptive way of writing it is we could say 53.8 meters per second. And then we could say 81 degrees. And so what is the 81 degrees, right? And it takes words. So you can't just leave it as 81 degrees. You got to describe it with words now, okay? So that means remember this is west and this would be north. So we're going to go north of the west, right? So 81 degrees north of west. And so hopefully you start to understand like, okay, yeah, it's way better to just give me the angle than the description, because we have to use, like up here, we went right to plugging it in, right? We didn't have to figure anything out. We know it's 120 degrees. Oh, we just put it in. Okay. All right, guys. So let me slide that up. Okay. In case you didn't have a chance to finish writing it. Okay. All right. And that's all there is to it. Now you could do this even with 3 vectors. Okay. Now I'm not going to get that fancy on you. Okay, I think 2 vectors is enough right now, but we are going towards the place where we are going to need to do multiple vectors, okay? All right. So for this next one, we're going to add the 2 vectors 62 meters per second at 20 degrees south of east and 22 meters per second, 50 degrees north of east. So I've given you descriptions, which is like, that's not helpful, right? I mean, it will help us in the sense that it will get us the angle, but we can't use the 20 degrees and we can't use the 50 degrees, right? We got to figure out the angle of rotation. Okay. So right now I'm going to do the 20 degrees south of east, and I'm just going to it can be a really quick sketch. Okay. This is west, this is east, and this is north, and this is south. So we're going 20 degrees south of east. So we're starting in the east and we're going to rotate towards the south, and that would be this angle right here. So that would be my angle of my triangle if I were to draw the triangle. All right. And the rotation, I'd have to go all the way past here and then back up 20 degrees. So I'd have to go all the way around, which is 360 degrees, and then back up 20 degrees. So my angle theta is 360 degrees minus 20 degrees, which gives you an angle of 340 degrees. Okay, so now we know vector u is 62 meters per second and at 340 degrees. All right, and then we're going to have to do 50 degrees north of east. So 50 degrees north of east, again, this is west and this is east and north and south. And we're going to, from the east, right, remember that's the start, we're going to have to rotate north 50 degrees. So that'd be somewhere up in here, and this would be 50 degrees. And so this is our angle that we would need to rotate, right? So that would mean our angle of our triangle is 50 degrees, but also it's the same as the rotation, right? So theta, our direction angle, is also 50 degrees. Okay, so my vector v, and you can call these any letters you want, okay? There's nothing special about u and v. If you want to call them a and b, that's fine, all right? So u and v, okay, so the vector v would be 22 meters per second at 50 degrees. Okay, so the horizontal components. So u sub x would be 62 meters per second cosine of 340 degrees. And v sub x, I'm just going to do both horizontals at the same time. V sub x would be 22 meters per second cosine of 50 degrees. All right. And then v sub y, actually u sub y would be 62 meters per second sine of 340 degrees. And v sub y is equal to 22 meters per second sine of 50 degrees. Okay, so that means my r sub x, my resultant vector, right? The vector I'm trying to figure out, okay? The horizontal component would come from taking 62 meters per second cosine of 340 degrees and adding to that 22 meters per second cosine of 50 degrees. And then we'll put that into our calculator. And so 62 cosine 340 and then plus 22 cosine of 50. And we get 72.402. And that's in meters per second. Okay, so that's the horizontal component of the vector I'm trying to figure out, all right? And then r sub y is going to be 62 meters per second times sine of 340 degrees plus 22 meters per second sine of 50 degrees. And so putting that into our calculator, okay, we'll put in 62 sine of 340 plus 22 sine of 50. And we get negative 4.352. Okay, so then the resultant vector r, right, would be the square root of the 72.402 squared plus the negative 4.352 squared. Okay, so that would give you a length once we put it into our calculator. I'm going to just do the whole thing in my calculator. Square root of, in parentheses, 72.402 squared plus, and then negative 4.352. Whoops, 4.352. Close the parentheses and square. And we get 72.5. So 72.5 meters per second. All right, so that if we were to draw it to scale, that would be the length of it, right? Okay. All right, so now we know we're going to go to the right and then we're going to go down. So that's the location of this. Okay, so we're going to go to the right, 72.402. Meters per second. And then we're also going to go down because the vertical component's negative. So I'm going to go down. And I'm going to go down 4.352 meters per second. I should have said this is meters per second. Whatever the units are for the actual vector, the components will be the same units. Okay, and then this is our R. And I know it's 72.5 now. Okay, and now it's a matter of getting this angle of the triangle, right? And once again, and notice, okay, so I'm going to keep saying this. Notice I drew the horizontal one first, and then I drew the vertical one, right? Okay, because then that forces this one to be my opposite leg for that angle. Okay, so alpha is going to be tan inverse. And once again, because we're thinking of this as a triangle, this is going to be positive 4.352 over 72.402. And when we put that into our calculator, it's going to give us actually a small angle. And 4.352 divided by 72.402. And yeah, 3.4. So this is 3 degrees. Okay, so I want you to round the magnitude of the vector to 1 decimal place, and I want you to round the angle to the nearest degree, and that's going to be good enough. That's going to be good enough for what we're doing. All right. Okay, so that we're not done because we need to get this angle of rotation, right? We got to get all the way to here, and that's my angle theta. Okay, so we have to recall that we have to go all the way once around, right? All the way back up here to this positive x-axis, and that would be 360 degrees. And then if I backed up, I'd be where this arrow ends then, okay? So my angle theta is going to be 360 degrees minus 3 degrees, which winds up being 357 degrees. Okay, and once again, this is, I should say 300, we use the 360 degree angle here to figure it out. This is west, and this is east, and this is north, and this is south. So when we go to write this up, we could write 72.5 meters per second, and we would say at 357 degrees. Or we could say 72.5 meters per second. As describing it, we could say 3 degrees. And we start on the east and we rotate to the south. So that'd be south of east. Okay, and there's 2 ways to write that vector up. All right. Okay. That's it, guys. I have one example that we're going to do. That's kind of a unique situation that we will do in class together. Okay, it'll be one of the extra examples. Okay, but that's it for the Edpuzzle video. All right.